Bum, bum, dum, ba-dum, bum, 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 bum. Welcome back. We are finishing up our chapter 11, at least the portions that I'm going to deal with for this year. And we're dealing with the idea of samples. When you take a survey, when you conduct a survey, when you're trying to find out information about a population, from the population, what's their opinion of things? What do they feel about? How do they feel about global climate change? You want to ask people this question so you can make some predictions and find out what's going on. You would love to be able to ask everybody in the population, but no one has that much time or no one has that much money to be able to conduct a survey that's going to ask everyone in the entire population. So we have to narrow it down. We have to take a sample of that population. And when you take a sample, there's basically 4 kinds of ways, at least that the book describes them, of selecting people from a population. You could ask for volunteers. Okay, tell me, who wants to be involved in this survey on, global climate change and whether it's good or not. Okay. And that would be called a self-selected sample. Okay, a self-selected sample. They volunteer for it. Okay. Or you could have a convenience group. You can say, okay, I'm going to ask people about climate change, but gee, I don't feel like going very far. I don't have much time, so let me just ask the people in my house, because they're right there. I can just ask them. This is a nice convenient group, convenient sample. You can probably start to see where some problems might arise with that kind of sample in predicting for the entire population. So you might want to do a systematic sample where you have some kind of rule or some kind of method of selecting people. So you say that, we know that the normal population of the country is 53% female, 47% male. So you say, I'm going to make sure that my sample is 53% female, 47% male. Or I have to make sure I'm crossing my age group, so I have young people and old people in a relative proportion to what the actual population is. That would be a systematic way of doing it. And what's most commonly done is a random sample, where you randomly select people from the office. They used to use phone books. I don't know what they do now to randomly sample populations. Now, when you do these samples, you got to remember that a survey, if you're trying to make a prediction with a survey, you want to have the most unbiased, unbiased information in order to make a prediction. Okay. So if you have an unbiased sample, or you could have a biased sample. Okay. Now, bias, that means that you're leaning towards something. Okay, bias and 2, and you can figure out what the rest of it is. That means you're leaning towards something, biased. Unbiased means you're not leaning towards something. You have a nice, even idea of what's going on. With unbiased samples, if you do random selection, you probably will get an unbiased sample. If you have a representative of a general population, like when I said a systematic sample, okay, you were more likely to get an unbiased sample than if you did a convenient sample or a self-selected sample. Okay. Those tend to be biased because of the way that you chose the people. Okay. So I just want you to get those words, that vocabulary down. Biased versus unbiased samples, and randomly selected, that's the main thing to do. The main part of the math that you're going to be doing in this section has to do with this idea of the margin of error. Okay. When you conduct a survey, you sample out. By taking a sample, you automatically introduce an error, a prediction problem. Okay. And the smaller your margin of error, the more predictable, more you can use that survey as a predictor. And here's the formula. It's not too difficult. That's a plus or minus sign, plus or minus. That's a 1 divided by the square root of n. N being the number of people in your sample. So let's take a sample size of, say, 750. Okay. So we do our plus or minus 1 divided by the square root of 750, which is pretty straightforward and easy to do on your calculator. Any calculator will do it. Let me just clear all this, clear. Okay. So you got, I don't think you can see this. You got 1 divided by second square root 7 Enter. And I get 0.0365, or about 3.5%, 3.7%. So this equals approximately 0.065, which is approximately 3.7% error, margin of error. So that's saying that if you said you did your survey and say 28% people felt that climate change was a really bad thing, that we need to do something about it, then your margin of error is at 3.7%. So that could be as high as 28 plus 3.7, or 31.7% could actually be saying it, or as low as 28 minus 3.7, that's 24.3%. So that's your error range. So like when you look at presidential surveys and they say, Biden's scoring at 47%, Trump's at 43% with a margin of error plus or minus 4%. You say, well, okay, so that really could mean that it's a tie. That one person could be, if it's 47 to 43, with a margin of error of 4%, and you say, well, that could actually be as low as 43, and that could be actually as high as 47. So you have to realize what you're looking at when you're talking about surveys and margins of error. Always look for that margin of error. There's one more thing we're going to do with this margin of error is go the other way with it. Let's say you had a survey and the result was 4% margin of error. Okay. Well, we know that 4% is equal to 1 over the square root of n. We want to know how big that sample size was. Okay. So we say, what's 4%? That's 0.04. And in order to get there, to get back to n, we got to do everything backwards. Okay, so we ended up square rooting and then inverting. So now I want to take this thing, I want to invert it. 1 over 0.04 is going to equal the square root of n. And then I'll square it. Now to invert that, you can use this x to the negative 1 button. Okay. So if I put in my 0.04, it's getting hard to see, and I press that x to the negative 1 button. See, it's got the little negative 1. It's inverting it. And I hit enter. And now I'm going to get that number inverted. Okay, so that says 25 equals the square root of n. And then we just square that number, x squared. And you know that your sample size was 625 people. Okay. So with a sample as small as 625 people, you would get a margin of error of 4%. Okay? We already saw that with a sample of 750 people, the margin of error is 3.7%. Now, in statistics, a margin of error around 3%, that's called reliable. That's called reliable survey data. When it gets above 4 and 5, it's not very reliable. So that's another reason why you want to learn this. So when you look at data, when you look at surveys, you look at statistics, especially now as a presidential race is coming into play, you want to be able to interpret that and understand what they're saying to you. So you're not fooled by statistics. Okay? That's why we become educated in mathematics. All right, so I'll post this up there and give you some assignments, tasks to do with it. But hey, margin of error and sample size, that's the big thing for you today. Where's that margin of error there? 1 over the square root of n. N is the number of the sample. All right, take care.